So this is Wokwi.com, which is a free website. Actually, if you were to just go to the basic website, this has 4 different types of boards you can work with in order to do this here. We'd make the Raspberry Pi Pico. These are some sample projects that you can work with the Raspberry Pi Pico. I'm going to pick the traffic light, as I like this one as my favorite example, right? So in here you have code on the one side and a circuit board on the other side. It's kind of an excellent example of how you can program and simulate at the same time. I'll walk you through this simulation real fast, as I think it's relatively easy to understand, right? Using code, you define the word red related to pin number 1. You define yellow as 5, related to pin number 5. And you define green as related to pin number 9. If you notice on here that there is connections, if I hover over this is general purpose 1, GP1. And you go down, this is GP5 for the yellow, and GP9 for the green. I'm going to make another one in here just for the fun of it. Define blue as, well, where do I want a blue? Where do I want a blue to go here? I'll put the blue on the other side. GP27, why not? So I want to make it as 27 for this, right? Next, there's this setup for this area right here, where they define what the pin modes are going to be, and they define them as inputs or outputs. Inputs can be certain pins on here, outputs can be others. I'm going to add one onto this right here, is in pin mode, and then blue. Oh, I spelled it funny up there. And I'm going to also define this as an output, and then parentheses, and I need a semicolon to end the sentence with that. That's just syntax for this here. So now I also should probably add a LED to this here. So I'm going to add 2 things. I'm going to first add an LED, but I'm also going to add a little resistor for this as well. This resistor, I'm going to tie this to general purpose. Most LEDs need some form of a resistor in order to block the flow of current going through them. I'll make this one, we'll make this one like a 270 ohm resistor. Notice it changes the stripes accordingly for those, so that's kind of nice to do. Next thing I'm going to do is I'm going to attach the LED to the resistor. So I'm going to attach this down with this wire that's here. I think these wires, there's ways I can turn these wires. So I'm going to turn this wire kind of similar to the others into a blue. And if I wanted to, if I was like breadboarding this, for instance, I would have different colored wires for these things. And the last thing I need, they're all connected to various grounds that are right here. So I need a ground. I've got a ground right here. I forgot how many pins the microcontroller has, but I believe in particular this guy has something like 24 or 28 different general purpose pins. But 4 of those are actually analog inputs. They can measure specific numbers of things. Oh boy, does that look? That looks a little funky right there. Can I please move? Also, I'd like that to be blue. There we are here. Right now I've got a blue. That wire looks terrible. Can I redo that so that it looks maybe a little bit better? Now there, ground. There we are, and I'll make that the color black. Right now I need my LED to actually, well, do something for this here. That's kind of the idea for that, right? So here I've got in this program right here, it says, okay, make the green one go high for 3,000 milliseconds or 3 seconds. This is trying to mimic a traffic light, which actually, ironically, they got the program wrong for this. Then after 3 seconds or 3,000 milliseconds, turn the green goes low, so it's no longer going to have power, and then the yellow one's going to go high for half a second, and then the yellow one after that goes low, the red one goes high for, well, let's just make this guy right here 2,000 with it here. And I'll toss into this part of it right here another one, digital right, Bluh, we'll make that a high. So So we'll make my Bluh high for that, put a parenthesis in colon for that there. Now, ironically, they make it to where the yellow goes high again as it goes back to green. We know it doesn't actually do that, so we're actually going to get rid of that in there. But then afterwards with it, we're going to make the red go low. We'll also make the, I'll just copy a digital right over here, make the there we go, make the Bluh go low as well. There's my Bluh. Right, now if I run this, if I hit the play button that's right over here, I'm going to hit play, and it's going to run the simulation here. Hopefully we'll be able to see some LEDs. Sometimes it takes a while to, you know, have the servers and whatnot get something going here. So every once in a while it takes a little bit of some time, like this one kind of is. Or it might mean that I've got a mistake somewhere in here. So there's my green, yellow and red and blue are turned on, and it goes back to green again, and then yellow and blue. Now the cool thing is, if I were to go through this introduction to the Raspberry Pi and go for and install the Thani software and other kind of programming code things. This is all free, so anyone can do this, and there's very good step-by-step programming of how to do this. This is like the installation for how to sort of do all this, and then it gets into other details with resistors and LEDs and so on and so forth for that. But the main thing, what to do with that is, if you were to straight up just copy this entire code and load it onto a Raspberry Pi, and you were to connect up wires to the Raspberry Pi that you have, kind of like a breadboard, that would actually function. This would work exactly the same. We built ours almost identical to this, and actually I think identical to this, with the exception that we gave it a sample program of something on the back. That's that buzzing thing that's there. So yeah, so hopefully that's something you can give it a try with yours here. Walk through those guys there and kind of see what you think for that. All right, thanks a lot.